The universe is full of wonders. We often look to the stars for them, exploding supernovae, colliding galaxies, the silent dance of planets. But what if I told you some of the greatest marvels are not out there, but right here, buried beneath our feet? I'm talking about the echoes of human ingenuity, the ghosts of technologies so advanced for their time, they blur the line between science and myth. People of the past were not simple. They were explorers, experimenters, and engineers. They looked at the world around them, rock, metal, fire, and they saw possibilities. They saw the universe in a grain of sand, and from it they built civilizations. We imagine lucky accidents, gifts from the gods. This is a disservice. The truth is far more exciting. These technologies were born from the scientific method, observed, hypothesized, tested, refined. They failed and tried again. They created materials that heal themselves, machines that mapped the heavens. These weren't magic, triumphs of physics, chemistry, and engineering. In this exploration, we will dig into 5 extraordinary technologies: Roman concrete, the Antikythera mechanism, Damascus steel, Greek fire, and Inca agricultural systems. We'll strip away myth, follow the logic, and rediscover the genius that's been waiting for us all this time. Imagine a structure that stands for 2,000 years, battered by waves, shaken by earthquakes, baked by the sun, yet only grows stronger. This isn't science fiction. This is Roman concrete, opus cementitium, its unreinforced dome, seemingly supernatural. Myths spoke of blessings. Modern science revealed something more impressive. Brilliant geochemistry we're only now replicating. The mechanism is simple and elegant. Romans used lime, water, and volcanic ash, pozzolana, rich in silica and alumina. Mixed together, a pozzolanic reaction formed a stable, non-corroding binder. Within this microstructure, lime clasts dissolve when cracks form, seep into fissures, and recrystallize as calcite, self-healing stone. The Romans observed which deposits worked best, and systematically exploited this geological gift to engineer an empire. This dynamic chemistry didn't just resist damage, it actively repaired itself. Today, material scientists emulate it for bridges and even nuclear waste containment. The impact was monumental. Aqueducts spanning hundreds of kilometers, harbors withstanding the sea, iconic buildings that endure. Roman concrete was civilization's bedrock. By understanding its chemistry, we rediscover a blueprint for durable, sustainable, resilient materials. In 1901, divers off Antikythera found a corroded lump of bronze. For decades it was dismissed. A curiosity, perhaps a statue part or simple clock. Decades of study with X-rays and CT scanning revealed a portable mechanical cosmos, an astronomical computer of breathtaking complexity. Inside were at least 30 interlocking bronze gears. Turn a hand crank, set a date, and its dials predicted the future. It tracked the sun and moon against the zodiac, showed lunar phases, even predicted solar and lunar eclipses with startling accuracy. A pin and slot mimicked the moon's irregularities, anticipating Kepler's laws 17 centuries early. Carefully calculated tooth counts and differential arrangements show mastery not seen again until medieval cathedral clocks. The discovery forces us to rewrite the history of technology. Precision-geared machinery is not just a modern invention. Turmoil, collapsing empires, and lost libraries silenced a tradition, leaving one miraculous artifact, humbling proof that progress is not a straight line. The makers translated celestial math into moving metal, the world's first known analog computer, modeling the elegant clockwork of the heavens. Swords that could slice falling silk, bend 90 degrees without breaking, and hold an edge through countless battles, Damascus steel. Myths spoke of sorcery and ritual. The real magic was in the crucible. The secret began with woots, high-carbon steel from India and Sri Lanka, with trace elements like vanadium and molybdenum. Smiths heated ingots in crucibles with specific leaves and glass, tuning carbon and its distribution. Then, slowly forged, hammered, folded, shaped at relatively low temperatures, unlocking microscopic order. Trace elements promoted aligned cementite nanowires. These hard carbide bands made the damask pattern and exceptional performance. Hard carbides kept a razor edge. Softer steel absorbed impact, hardness and toughness in harmony. The knowledge faded as unique ores were depleted and masters died. Without the right ingredients, the recipe failed. Reverse engineering Damascus taught how microstructure defines properties, principles now guiding aerospace alloys and medical materials. 7th century sailors closing on Constantinople faced a torrent of liquid fire from bronze tubes. It burned on wood, sails, even water. Dousing it only spread the flames. Greek fire, the Byzantines' most feared secret technology. The myth hid a guarded formula. Though lost, accounts and chemistry suggest a petroleum base, crude oil, naphtha, thickened with pine resin. Sulfur and quicklime likely featured. Quicklime reacts exothermically with water, intense heat that could ignite and worsen wet fires. Effectiveness hinged on delivery. Heated cauldrons pressurized the mixture. Bronze siphons projected the stream. Handheld and ship-mounted variants. The result dominated Mediterranean naval warfare, an ancient analog to the modern flamethrower. Kept by a few families, the secret vanished with conflict and collapse, illustrating how siloed knowledge dies with its keepers. Reconstructing possibilities teaches the history of chemical warfare and the ingenuity and peril of applied chemistry. High in the Andes, the Inca flourished in an environment of steep slopes, thin air, and extreme temperatures, hostile even to modern agriculture. Myth credits mountain gods. Reality credits Andines, sophisticated, sustainable agricultural engineering. Stone retaining walls backed by 3 layers. Bottom, coarse stones for drainage. Middle, sand and pebbles. Top, rich topsoil carried uphill. The system formed a perfect growing medium and a thermal battery. Walls absorbed heat by day, radiated it at night to fight frost. Linked canals, aqueducts, and reservoirs delivered controlled flow from mountain springs, hydrating every plant, minimizing waste. Altitude created microclimates for potatoes, quinoa, maize, and beans, a vertically integrated agricultural laboratory. Conquest shifted priorities to mining and flatland monoculture. Terraces fell into disuse, generational knowledge faded. Today, engineers and agronomists rebuild Andines as models for sustainable farming, erosion control, and water management, ancient answers for climate change and food security. We have journeyed from Roman concrete to a Greek cosmic calculator, felt Damascus heat, witnessed Byzantine fire, and stood on Andean stairways. The recurring truth: human ingenuity is not modern. The past is not a dim museum, it's a library of forgotten blueprints. Knowledge is fragile, shattered by war, eroded by secrecy, rendered obsolete by change. Greek fire vanished with its guardians, Damascus art faded with its ore. Using electron microscopes, CT scanners, and mass spectrometry, we translate stone, metal, and ash into the language of physics and chemistry, finding tangible solutions. Roman self-healing inspires smart materials. Inca systems model resilient agriculture. Studying lost marvels connects us to fellow scientists and engineers of the past. They were observers, tinkerers, bold thinkers. The universe still holds secrets, in the stars and in the dust beneath our feet. The quest continues, guided by echoes of ancient genius.